Hey everybody, in this video we're going to take a look at the agentic dev team, which consists of 4 static agents and there's no limit to how many agents that this can spawn up, so it can go up to over 10 agents. So let me show you some of the apps I was able to build with this. For example, I built this calendar app in TK Inter. You can actually set events, let's just say one, and these events are visible in the weekly view, monthly view. If we were to add another event, for example, two, then we can see them here. Now 2 green dots are added. We can go through the months, go back to today, things like that. So this was pretty awesome. Now the important part of this is that this builds multi-file apps. This app is over 600 lines of code. Another one it built is this Chat GPT clone in TK Inter. Here we go. We can send a message here. It's not the best design, but it works. Here we go. You can start a new conversation. The conversations are stored here automatically. You can say, tell me a joke. And here is the joke. So we can go back to the first conversation, continue it, or delete this conversation. Conversations are stored here along with there's a chat app config. Now this one is also made up of multiple files, plus it writes the requirements itself too. Another one is this diagram app that it built. Here we go. We can draw rectangles. We can move them around, draw lines, can adjust the line width, toggle a grid. So we can also undo and redo. So these are all multi-file projects. So the previous version of this, over which I made some significant improvements, which we'll talk about, was agentic game dev. It was this video if you want to take a look at it, but that was configured to build only games. This one, however, can build any Python project. There's a caveat, which I'll talk about. By the way, the code files for this project will be available at my Patreon at connoisseur level. That is the $30 level and above. Link for that will be in the description, but we will be reviewing the code here shortly. You can also build games. Take a look at the space shooter game. It's made up of 10 files, and this is over 900 lines of code in total. Now, this is pretty significant because each one of the agents that spawns is responsible for an individual file. So the agent that writes the enemies.py file doesn't know what the config or the game.py file is going to look like, as well as none of the other files. The common ground is this project plan.xml, which we generate during the planning phase, along with the summary and description of each file and imports and to the general basic description, along with the program logic, which we use throughout the process, the agentic process. So if I launch this game, it's not the most beautiful game, but the surprising part is that it actually works. And it has levels along with actually upgrades and things like that. Yeah, so a total of 900 lines of code. It autocorrected itself multiple times. This was very surprising. So before we begin reviewing the code, let me tell you a little bit about how the overall structure, logic flow of the app works. But if you also wanted to gain more insights, you might want to watch this agentic game dev. You can find it at my channel or at my website, echohive.live. You can download the code for that at my Patreon as well. So to begin with, we're taking user input, and the two of the static agents is the planner 1 and the planner 2. So these two talk to one another for as many iterations as we have specified. And eventually they generate a game plan. After the game plan is generated, the game plan includes all the files that is need to be generated. So however many files there are, we spawn up individual agents. Let's say in this case, there is 7 of them. And each one of these actually write their respective files independent of one another. And when their common ground is, of course, the game plan. So they don't know what each other is doing at this point. After that, we entered another static agent, which is the error correcting agent. So this actually runs the code and tries to correct any errors that might be occurring. This is pretty effective. Now, once all the errors have been corrected, then we enter a user feedback loop where we run the app, the user interacts with it and provides feedback, and this agent actually improves on it. So this means we have 4 static agents, and there's no limit to how many dynamic agents that this system spawns or brings to life. Okay, now we can begin reviewing the code. I have also in detail reviewed the code in the other video, but I made some significant improvements to it, along with making it more generally applicable to any Python program. However, this system, because it uses subprocess to run the code, to execute the code, is not really appropriate to building or executing or actually applying to the kind of applications which takes in user input from the terminal. Due to this, I'm actually going to work on it. If you do download the code or have suggestions on how to make this better, do let me know. So any app that takes in user input from the terminal will just not be the appropriate program to build with this. But other than that, you can build any Python program. Let's quickly run it and see how it works. When we first run it, we get a warning saying that this will execute code on our machine and can be potentially dangerous. You have to type here yes to accept it. And then it's going to ask us if we want to create a new project or open an existing project. This can continue from your existing projects. So let's actually go ahead and say one. And before I continue, the project folder is where all the files are going to be saved. You can then copy this and rename it if you want to keep that project. So it's going to ask us if we want to clear the project folder. We're going to say yes. So we are starting fresh. As you can see, the project folder is cleared. Now, describe the task or project you want to create. Now, this is where it takes in user input, but there is also an additional underscore instructions .txt file where you can put additional instructions or code examples. For example, this is what I did when I was creating the ChatGPT clone in tkinter. I inputted some sample code on how to call GPT API. But let's say we wanted to create a fully functional calendar. I have some tests here, which I'll also include in the code download. So once we write our description for this is for a fully functional calendar app in tkinter, then it's going to ask us how many planning iterations we want. This is the step where planning agents are going to discuss while generating a game plan. So let's actually select 2 here. So for speed process, we see that additional instructions is empty, proceeding without additional instructions because we didn't add anything here. Otherwise, it would have get injected into the system message right here. We would have added it into under the system message for both planning agents. So now here we are getting the first planner to create some outline. As you can see, the first one is a critical expert in the domain relevant to the following task, and the second one is a project architecture expert. So they're going to have a discussion and discuss how best to build this. Now, on the final iteration, since we said 2 in the second iteration, we actually append another message saying that this is the final iteration so that they can gather their thoughts. And finally, this architecture designer is going to actually return some really detailed structure. Here is specified in these instructions. You see here, it is what's happening. In the second iteration, the first one actually outlines, and the designer is actually returning the XML, which we write to file here in the project plan, along with the logic flow. And then we spawn here in this case about 8 agents to actually write these files here. They are being written all in parallel in async. And after project creation is completed, we automatically run it. Here we immediately ran into an error. Here we are attempting to fix that error by sending that feedback back to the error correcting agent. Now it ran again, and now we are on to the second attempt. And here you can see the reasoning of the error correcting agent and what it thought should be happen to fix this code. Here it says which files need to be modified, and it also prints which file was modified in this section in this return of the error correction. So I'd like to mention that all of these apps that I built went through several rounds of error correction and also several rounds of feedback. Now, the thing is, this will run for up to 10, and after 10, it'll quit. All you would have to do is, if you wanted to continue, to run this project again and actually select the second option to continue from a previous project, and just select the project folder, which is what you were working on, right? Unless you wanted to bring in an external project. That is, if the project didn't reach to the level that you expected after 10 iterations of error correction and feedback. So here, actually, on the fourth try, we got this running. So as you can see, we can go to day and week. So some of the things are broken, but we can add an event. So this actually looks prettier. So once you close this, actually, some of the error messages that happen when running the code will get back to it. So it's actually good to run your program and interact with it for a bit, and then it'll continue fixing the errors for you. And once all errors have been eliminated, you go into the feedback loop and start giving it feedback. Now, I also have a line counter, quick little script, which actually counts the lines of code that is present in the project folder. We'll run that here in a second. But now, as you can see, let's see if we can add it. Both start and end time. So if the error message is occurring in the app itself, you may want to switch them to you may want to start giving. So since the app actually ran without any errors, now that particular error we would fix during the feedback loop, which we have just entered. But let's run this line counter real quick. If I were to run this, we can see how many lines of code is present in this project, which is 564. It also prints how many lines each file has. As you know, the outputs of these models are limited to 4,000 tokens. So that means you can write up to about 350 and 400 lines of code. So this wouldn't have been possible with a single line output like you would get from ChatGPT Web UI or Anthropic Cloud Chat. Now, the thing is that it's very difficult to write multi-file applications, especially since each of the agents that writes these files don't have any real knowledge of what the others are doing. So this is a more difficult process, actually, but I think this will be fruitful, more fruitful as the models get better. So now that we've seen how this works, let's go ahead and review the code. So it's a single file program, it's quite long, about 500 lines, but we use Anthropic, and we are using the latest Claude 3.5 Sonnet. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses, and my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Let's start at the end with the create project, which is the main loop. So here we take in a description for a project, and then we ask how many planning iterations does the user want. This is the part where the planner agents talk to one another. Now, I found that usually 3 or 4 works well. If you actually set the iterations too long, then they just start making stuff up, it seems. But, feel free to test it out. I usually choose 3 or 4, but 2 is all right too. If you're in a hurry, you can set it to 1. Now, this will trigger the plan project function, which we will review. It will generate a project plan, which we saved a file, which is going to look something like this. This was for the chat application that I have built. This will include a logic flow too, which we will use. And then we create async tasks using the agent write file function, which is going to spawn or create an agent for as many file names there are. And then we run those and write them to the project folder. And then here we have the max attempt set to 10. Here we will enter an error correction phase by running the project with the run project function. Now, if there is no error message, then we will continue with taking user feedback. essentially, after the code files are written, we enter error correction, and if there is no errors, then we start taking user feedback. And we call update project files to write them to file. And if there is an error that occurs during the feedback process, we actually call the error correction phase as well again. Now, this can actually load your previous projects too. I forgot to mention that. In that case, we have the manage project. For example, in the beginning of the script, we ask if you want to create a new project or start from an existing project. So you can put a folder here, and it's going to ask you the folder name. And after that, it is going to copy all the files into the project folder and continue with the error correction and feedback phase. So we will, in this case, if you load another project, we will skip the planning part. So now let's go back to the beginning and see how this works. At first, we print some messages. We do print a warning. The script will not may, but will execute. Code on your machine can be potential dangerous, so you have to accept this because this code will be running executing code for error correction phase. So here I have this other file called additional instructions. So you can actually put instructions here, for example, or code samples if you want it. This will handle everything for you. If it's empty, no worries, because it has a chat loop here. Perhaps I should run it so we can see how it works. Next, we have a function called clear project folder. This is going to ask user if they want to clear the project folder, which is the main folder, where the main project folder, then it just clears it. Another function is necessary when working with Anthropic API, add separator between consecutive user messages. So sometimes due to us appending additional user messages to the messages list and Anthropic not accepting two consecutive user messages, this just inserts a arbitrary assistant message with three dots in between them so that we don't get API error. Now, here is the planner agents, plan projects, which takes in a task description and iteration number. It reads the additional instructions, if any, and then you can read this in detail, but the first one is a logical critical expert in the domain relevant to whatever the task description is. The second agent, this is the system message for the first one. This is the second one. It's pretty much the same thing, but is a project architecture. So the first one is going to recommend stuff, and the second one is going to try to actually put it into some kind of order. The important things here is that all files need to be in a single folder. It's important that the files are not put into a separate folder under the project folder. So do not create any folders for the project, that is. So all the files need to be just strictly under project folder. And another thing is that we don't want it to create any unit tests. They're not very helpful to us. And we want it to print all messages within the files, meaning with print statements to terminal, and not to a log file, or especially not use logging, so we can get accurate error messages when running them with sub-process. So if you find a better way of doing this, please do let me know. And we don't want it to refer to any external files, especially when building games, unless the user provides them and provides them in the instructions. Another important thing is that we want this, since the subprocess is going to run a main.py file, we want the main entry point to the program to be in the main.py file as a main function within the main function. And the main function should not take in any arguments. So those are really important. Other than that, these two will engage in a talk. Here, after defining the system messages, for the first one, we add please plan a project based on the task description. The second one, we don't add any because it's going to take in the input of the first one. Then we enter the iterations. And we pretty much run this by calling Claude, right? But when we are at the final iteration, to the first agent, we append that this is the final iteration. Please provide your final project structure. And we iterate some other important stuff, such as don't return any directories, just the file names and descriptions, and make sure to mention what dependencies and libraries are necessary for each file. And again, we do the same if it's final for the second agent, but this one actually is going to review the project design carefully and provide your final response in this XML format. which is going to include an overview, components, files, each file along with their description. Also, at the end, we also say it to include a requirements.txt, which may be out of date, but it's there anyway. And also a logic, which describes the logic flow of the app, which we're going to use in the error correction phase and the feedback phase. Yeah, and some other instructions. And then we make sure that we add the separator in between them. So this is just a planning loop. And at the end, we get the XML content, we extract it, and we get the XML content in this case and return it. So this is what that function does. Now, agent write file is actually for, this is the agents that actually write the files. So this is going to be instantiated for each file there is. For example, if you were to go back and look at the space shooter game, there's about 10 files. So this function will be called 10 times in parallel. You can see that you're an expert in creating files for a project like this. Here again, we reiterate that the main function in the main.py is the entry point. We do want to say this is really important that it returns the full code always, and do not say something like the rest of the code remains the same or stuff like that. And we don't want it to redact the code. Pretty much that's it. So we pass that's the system message here. We pass the file name, which comes to us from the project plan. As you can see, each file has a description. That is what we pass here. We say you're responsible for this file with this description, but we also pass in the entire project plan. So it has a general idea of what's going to happen in this project. Always return the full contents of the file, and it just pretty much returns it. We split it, we take it, and we write it to file. This parse file structure is for the it's for getting the XML structure out of the agent's final plan. Now, fix project files is where we actually fix the errors. We open the project plan and we only extract the logic element for this case. So we are not really, because at this juncture, we are actually going to be loading all the files into the model's context. So it's going to know what the entire project is about, this error correction agent. But to kind of center it or anchor it, we do grab the logic part of the overall plan and we insert it so that it actually knows and it doesn't go astray. You can maybe think of a better logic here. Other than that, we grab all the files from our project folder, right? Such as like this, and we append it into a file contents dictionary. So now we give it some instructions, such as it's an expert in fixing errors. We do give it a reasoning step, and now we instruct it to return XML tags with each file name. Always return the full code for each file. Now, that is the system message. In the user message, we say that an error occurred because we will be executing the code, and if there's an error message, that's why we are here. We pass the error message. We pass the entire contents of the files, project files, and also we pass in the project logic flow into it. And then please analyze the error, provide a corrected solution. And it's going to reason about it and hopefully provide us with some correct solution. So from my experience, when you run this enough times, it's very good at fixing errors. Sometimes it repeats itself, but it works. So the next function is to update the project. So this is the update project files. So function is the feedback loop. Again, we grab all the project files, okay, from our project. We get the file contents. We get the project plan from this XML file. And then that is the same thing we've done. And here is our prompt. Here are the current contents. User has provided this feedback. This is what we have written here. And on the project logic, please analyze the feedback. And this can actually manipulate multiple files. After a reasoning step, it returns the files. And the prompt is ahead of the system message here, but the same difference. You are an expert in updating the code. Again, we reiterate some of the important stuff, such as do not redact the code, return full code, main function in the main.py is the entry point, okay? And now we make another call, as many as necessary. And here is the run project. This is actually to capture the outputs and the errors. Do we use subprocess to run it? project folder can be customized here at the top. You can also change the print response to false if you didn't want to read all this stuff that we were looking at, such as these. The reason is because you can actually run this in two different terminals, like I have right now. You can actually go here, split a terminal. So if you were to do that, you can run one, and then you can also come here and say like project two. So you can run this system at the same time in two separate terminals. As a matter of fact, even three separate terminals, if you so want it. If you change the project folder here, then they won't overwrite one another. That's all. Okay. So at the run project file, we run it, try to capture. Here we print a message project is running. Please interact with it. You can close it too, but this is really where we capture all the outputs and the errors. Do interact with your project if it's like a window, so we capture as much stuff as possible. And once we have it, we return it with the output or the error summary. Okay, otherwise we return none. We can exit the error correction loop. Now, open existing project is just kind of like a helper function, which is going to ask for a project path. For example, if I was working on the space shooter game and from before, and I were to bring this folder here, I would actually enter this folder name. And what this is going to do is it's going to copy all the files under here, under the project folder, and then it's going to continue. So manage project is going to ask us if you want to create a new project or open an existing project. If it's one, it's going to go through the process of whether to clear the project folder or not. It's up to you. And then it's going to await create project, which is the main loop that we examine. It takes a task description, iteration, and it runs the general loop for us, including planning the project, writing the files with async IO, and entering an error correction and feedback loop. That is if we were to select one. If we were to select two, then we're going to open the existing project using this function. Okay. And then again, we're going to enter the same loop as we've just seen, but there's going to be no planning part of it. Other than that, everything else remains the same. That's it. And then we run the manage project, which is our main function with async.io.run. So that's it. This actually works really well. I'm working on improving it. Do let me know what you think. Maybe if you like this, I'll make a live stream. We can test it out together. So I'll include all the projects that I built with it, along with all the other necessary files, which will be available for download at my Patreon, like I said, for Connoisseur Plus level, which is $30 and above. If you want to dive deeper into it, do watch this agentic game dev, which was really the birth of this project. Also, I've created another project called Agent AGI, which is a much more powerful system, and it's not restricted as this one. This is what I call a restrained or restricted agent process, which usually ends up having better results. But like I said, these two are really one of my best projects, which are the same, but I keep updating it. Agent AGI is also available at my Patreon, but that's for Architect Plus patrons at $50 and above. Take a look at that too. Also, I started posting much more on X or Twitter. My handle is hive_echo. I post more videos here, some short examples. Do follow me there if you're interested. And on my Patreon, I have tiers with which you can actually connect with me one-on-one if you needed some consultation or needed some help with your projects. I have 1 hour every month and 3 hours every month tiers on my Patreon. I also started having Ask Me Anything sessions with Architect Plus patrons every week now at different hours. Check that out as well. There should be a link in the description for that as well. Thank you for watching, and I'll see you in the next one. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. and my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.